So I'll start with the why first. Basically, what I wanted to do was experiment with 360-degree motion, but more specifically, I wanted to experiment with contra-rotational movement. Through research, I couldn't even find reference to any equipment that would allow me to experiment with this kind of motion. So I had to build this rig myself. It took 2.5 weeks to build, working 6 hours a day. What we've got here is a safety brace. At the moment, obviously, there's a mannequin on the top, but we did have human beings at the top here too. So what I devised was a safety system, and basically what you've got is a safety belt with 2 steel D-rings here and here, and a very large carabiner steady in the middle so that the subject can move forward or back but is held here. But also one of the functions of the safety brace is that it can be adjusted for varying actor height. So if you've got a small child, we can have the carabiners down here, or a larger adult where their waist is higher up, you can then move the carabiners up. Moving down, you've got the pedestal top. This is basically wide so when somebody's standing on here, that they can't get any of their limbs, legs, they can't get them down here, which is in the path of the arm. We've got inside the structure 2 bearings, and this is what allows the apparatus to have this contra-rotational movement. It basically isolates the movement so that we can go 360 here, but also that this arm can move independently of the top. So whatever direction the top is going in, we can choose which direction we want to go with the arms, and that is the essence of contra-rotation. Basically, we have triangulated reinforcements at set equal intervals to offer maximum strength. When these are weighted, they push down against these pads and they're in compression. Also, on the longer boom arm, you'll notice this trellis system here, which as an engineering principle, the trellises are in tension, which gives rigidity and strength to the arm so that it can then take the weight on the end. Also, you'll notice 2 cages that were built. These cages were built to house, on the longer boom arm, to house the lighting equipment, and on the shorter arm, various weights, either cans of water, or sandbags, or concrete blocks like we have here, depending on how much weight is on the opposite end. Obviously, the idea is to balance the system. Also, on top here, we have a ratchet strap that is hooked into one of the triangulated reinforcements, and what this does is basically goes across the length, hooks in here, and what that does is basically pulls the arms tight to the centre of the cage. Also, the actual arms themselves, everything is detachable. So this pedestal comes off, the safety brace comes off, these arms come off, and basically what you've got is a solid piece of steel rod that basically goes about so far into each of the arms on either side, so the arms slide on to here. So that allows them to take the weight, and then they are ratcheted together to stop them from sliding out. It was designed with motors, so there would be a motor fitted inside this cage, a Parvalux geared motor that runs at 7 RPM. That was going to be housed in here and was going to drive a shaft for the top section. There was going to be another motor, which was also bought and which was in the original design, that was going to be mounted here with a coupling that would basically turn from a shaft, turn just this cage section. The motor housed in here would have needed to have run on 2 12-volt batteries in series to create the 24-volt DC current needed to run the motor. It would have also needed something called a battery brain, which is a remote on-off for the battery. Now, the reason why it has to be remote is because yes, now I could click a switch and get this motor turning, which turns the top, but when the arms are in motion, if that top is still turning, if they suddenly want to stop on the top there's no way I can reach in to turn it off because these arms are still moving. So it has to be a remote fob switch that I could basically click on and off, and the bottom motor would run from a cable to a handset outside of the reach of the arms, which would then be operated. This is something that I will continue to develop. The power inverter and the battery. Obviously you can't run any lighting equipment on the end of this arm mains because cable would foul as the apparatus spins. Okay, so what I'm going to demonstrate now is the motion that is created by this rig, and basically its raison d'etre, its reason for being. First of all, I'll demonstrate standard 360 motion. So basically, as we turn the pedestal, the subject moves through 360 degrees, in this case in an anti-clockwise direction. And notice that it just runs via the bearing. It will actually just travel around just by giving it a gentle push. The pedestal and the arm are moving in the same direction. Now what I'll show is the contra-rotational directions that I wanted to investigate from this rig. So I will spin the centre anti-clockwise, and I will spin the arm clockwise. So as you can see, this is contra-rotational movement. The centre moves in one direction and the arms move in the opposite direction. Then I will move on to the placement of the camera and the placement of the lights. Now, this rig was built to be dual function. At the moment there is a projector on here. This projector supplies a straight beam. There is a laser plumb here, which basically provides another vertical straight beam that goes inside of the projected light beam from the slide projector. Now, it's dual function because you can also mount the camera on this end of this arm here by means of such a tripod system, and basically mount the camera on here, which then gives a standard 360-degree shot. If you could imagine a camera on here now, looking in at the subject, and if you see, as we go around with the arm, this would provide a standard 360-degree shot of the subject, which we could then have and move this the opposite way, and we would have a contra-rotational shot. And it was built for a reason, not for the fun of it. It was built because there was nothing else like it and nothing else that I could use to experiment with contra-rotation. Another option would be to get a 360-degree track, but this system is more efficient because lights or camera can just simply be mounted on this arm, which is free floating and which doesn't require anyone to push a dolly as you would have to do with a track. So yeah, that's basically it. It's strong, it can take a lot of weight, and it's a very successful piece of equipment, and I enjoyed fabricating it and using it.